or wonderful, because the volcanoes of Io are constantly producing chemicals, materials that rain down onto the frozen surface of Europa. But if it wasn't for the geology, then they'd be separated forever from the ocean below by 10 or 20 kilometres of ice. But that active geology, creating the plate tectonic-like behaviour, can bring those materials, those chemicals, into the ocean. And then we have all the conditions we think are necessary for the origin. It may be far more likely that we are alone for millions or even billions of light years.
The volcanoes of Io are constantly erupting, releasing chemical materials that rain down onto the frozen surface of Europa. Were it not for the moon's dynamic geology, these materials would remain forever trapped beneath a vast sheet of ice, 10 to 20 kilometers thick, never reaching the ocean below. However, Europa's geologic activity, akin to plate tectonics, enables these chemicals to be transported into the depths of its hidden sea, creating conditions that scientists believe are essential for the emergence of life. If such processes did not exist, life might be a far rarer phenomenon, perhaps even absent across millions or billions of light years. Beneath Europa's icy surface lies a mystery that could redefine our understanding of life in the universe. Scientists have uncovered compelling evidence suggesting that Europa does not merely harbor frozen water, but a vast liquid ocean, one that may contain more water than all of Earth's oceans combined. Unusual chemical signatures and unexpected heat patterns hint at extraordinary processes occurring beneath the ice, bringing us closer than ever to discovering extraterrestrial life. The discovery of Europa's hidden ocean. In March 1979, NASA's Voyager 1 and Voyager 2 space probes passed near Europa as part of their grand tour of the solar system. Voyager 2, flying at a distance of 118,000 miles from Europa's surface, captured high-resolution images that sparked scientific speculation about the presence of a subsurface ocean. Subsequent observations from the Galileo spacecraft in the late 1990s strengthened this hypothesis. In 1997, Galileo flew just 124 miles above Europa, detecting anomalies in the moon's magnetic field, an indication that a vast, electrically conductive liquid, likely a saltwater ocean, lay hidden beneath its icy shell. Scientists estimate that this ocean lies between 6 and 18 miles beneath the surface, potentially stretching to depths of 60 miles. The implications were profound. If a vast ocean exists beneath Europa's frozen crust, could it harbor life? The possibility set the stage for further exploration, culminating in one of the most ambitious planetary missions in history, NASA's Europa Clipper. The Europa Clipper, a $5.2 billion search for life. On October 14, 2024, NASA launched the Europa Clipper, the most expensive planetary exploration mission ever undertaken. Aboard a SpaceX Falcon Heavy rocket, this colossal spacecraft, spanning 100 feet with its massive solar panels, embarked on a 1.8 billion-mile journey to Jupiter's enigmatic moon. Designed to conduct the most detailed study of Europa to date, it carries 9 advanced scientific instruments, including an ice-penetrating radar to map the moon's interior and high-resolution cameras capable of capturing details as small as 20 inches across. The Europa Clipper is expected to reach its destination in 2030, after performing complex gravitational assists using Earth and Mars to gain the necessary velocity. Upon arrival, it will complete 49 close flybys, coming as near as 15.5 miles from the surface, closer than any spacecraft before it. However, the mission faces significant challenges. Europa orbits within Jupiter's intense radiation belts, second only to the Sun in their power, posing a severe threat to the spacecraft's electronics. To shield its vital systems, Europa Clipper has been equipped with a radiation-hardened vault, ensuring it can withstand the harsh environment for at least 4 years of scientific operations. But what exactly do scientists hope to find beneath Europa's ice? A world of water, energy, and chemistry. Europa is a world of paradoxes. Though its surface is desolate, bathed in relentless cosmic radiation and temperatures plummeting below minus 50 degrees Celsius, beneath the ice, conditions could be surprisingly hospitable. Scientists believe that 3 essential ingredients for life, liquid water, energy, and key chemical elements are all present in abundance. 1. Liquid water. The presence of a deep, global ocean increases the chances of habitability. More importantly, this ocean interacts with Europa's rocky mantle, allowing mineral-rich compounds to dissolve into the water, potentially supplying the nutrients necessary for life. 2. Energy sources. Despite its distance from the Sun, Europa experiences tidal heating due to Jupiter's immense gravitational pull. This tidal flexing generates heat by continuously stretching and compressing the Moon's interior. On Earth, similar conditions exist at hydrothermal vents on the ocean floor, where life thrives without sunlight. If volcanic activity exists beneath Europa's ice, it could create similar environments capable of sustaining life. 3. Essential chemical elements. Observations from the Hubble Space Telescope have detected carbon dioxide on Europa's surface, likely originating from its subsurface ocean rather than external sources such as meteorites. This discovery suggests that Europa's ocean is chemically active, possibly sustaining biological processes. Furthermore, NASA's Juno spacecraft detected atomic hydrogen escaping from Europa's atmosphere, implying that radiation is breaking down water molecules, releasing oxygen. If geological processes transport this oxygen into the ocean, it could further enhance habitability. These findings suggest that Europa's ocean has existed for over 4 billion years, nearly as long as Earth's. With the right conditions and sufficient time, could life have taken hold beneath its frozen shell? The search for alien life. If life exists on Europa, what might it look like? Most scientists anticipate discovering simple microbial organisms, akin to the bacteria found around Earth's deep-sea hydrothermal vents. However, some speculate that more complex multicellular organisms could exist, perhaps even predators in the deep, dark waters. One of the most compelling analogs to Europa's environment lies on Earth itself. In 1973, scientists discovered Lake Vostok, a massive subglacial lake buried beneath 2.5 miles of ice in Antarctica. Despite being isolated from the surface for millions of years, Lake Vostok harbored unique microbial life. If organisms can survive in such an extreme environment on Earth, why not on Europa? What happens next? Europa Clipper's primary mission is to analyze Europa's ice shell, ocean, and potential habitability. The spacecraft will search for plumes of water vapor erupting from the surface, similar to those observed by Galileo and Hubble. If these plumes contain organic molecules or even microbial life, Europa Clipper could provide the first direct evidence of extraterrestrial organisms. After completing its mission in 2034, Europa Clipper will end its journey by crashing into Ganymede, Jupiter's largest moon, another world believed to host a subsurface ocean. Future missions may target Europa's surface directly, sending a lander to drill through the ice and search for life more conclusively. A new era of space exploration. While Europa remains our most promising candidate for extraterrestrial life, it is not alone in its mysteries. Saturn's moon Titan, with its vast methane seas and subsurface ocean, presents another intriguing possibility. In 2027, NASA will launch the Dragonfly mission, a robotic drone designed to explore Titan's surface and search for chemical signatures of life. If life exists on Titan, it would likely be radically different from anything found on Earth, perhaps even methane-based organisms with entirely unfamiliar biochemistry. As we stand on the brink of discovery, the coming years may reshape our understanding of the universe.